Let's get started with this. So I'd like to welcome everyone to day 3 of PDC and for coming to this session on secure applications for SQL Server. And I'd like to thank everyone for taking time from their lunch hour to come and attend this talk. My name is Il-Sung Lee, and I'm the program manager for the SQL Server Engine Security team. So usually I deal with the server side and server-side security, but in this case, I'm going to start talking more about the application because the application is equally as important as the server in terms of securing your whole data. And before I get started, I'd like to get kind of an idea. How many people here actually consider security during their normal course of application development? Wow. OK, that's great, actually. So everything I'm going to talk about in this talk, the ideal situation would be that everyone knows this already. And so in that case, I mean, this would be kind of a rehash. But in case there is something that you don't know, then I'm hoping that you take something away from this talk in terms of additional things you can do to help secure your data with SQL Server. So I think the best way to do this is to start with a short demo. Does anyone have any idea about how prevalent SQL injections are in terms of the rating in terms of the web attacks? It's usually number 1 or 2. And typically, I think it was CERT last year that came out with a figure that said 1/3 of all web attacks, we're not talking just database attacks, all web attacks were related to SQL injection. Okay, so it's a very, very serious problem, and it's a very application-specific problem because there's very little you can do on the server to actually prevent this. So let's start off with a quick demo. So here, I have this ASP.NET application that it's just a web application. And so I create, it's basically a web app that just lets you enter a name and get the work status for a particular person. So for example, if I type Alice, then I see that Alice has the high priority works in progress, security training is completed. So she's not doing too badly. And then we can also try checking for Bob. And we see that Bob has his high priority work completed and his security training is in progress. So he's not doing too badly either. However, we have Mallory here. And we see that her high priority work is 1 week delayed and her security training is absent. So this isn't very good stats for her. So Mallory is thinking that maybe there's some way for me to get around this, and she's a little bit maybe unethical, but she wants to at least portray that she's on track. So what can she do? Well, the first thing is that in this application, we've kind of cheated. I've given you this T-SQL statement at the top of the application so you can see exactly what's being entered. Now, typically, if I was an attacker and I want to see if I can exploit this, then what I would do is probably just put a quote there, okay, and see what happens. And you see that the server returns an error. And often what you'll find is that you'll find that attackers look for exactly this string, the unclosed quotation mark after a character string. And this kind of signals to them that, well, it's very possible that this is susceptible to a SQL injection because what they're doing now is that they're clearly probably concatenating strings to compose their SQL query. So with that in mind, what I can start doing is I can start doing lots of stuff now, right? And the first thing I would do, and I have these things kind of spelled out already because I'm kind of slow with the typing. But the first thing I'd want to do is I want to kind of gather information and see if I can take advantage of this. So I use end quote, semicolon to end the statement, and then add whatever I want and put the dash at the end so that it comments out everything else after that statement. So in this case, if I submit it, you can see that I've automatically been able to get not only the schema, but the table name and the columns in that table. So already, if I'm Mallory, I'm thinking that, well, OK, this is probably the workload status is what I'm looking for. And so I want to make sure that maybe I say that I'm completed. So now that I have that information, what I can do is I can start injecting my own SQL into the statement. And instead of the select now, I'll put an update statement where basically I'm updating the workload status to be completed. So I submit that, and it's done. Now, of course, I'm seeing the old data. Now, if I just go and query Mallory again, you'll see that everything says completed. So at the very least, Mallory's a cheater. Okay? Now, worse off, she can be a criminal. In which case, I mean, there's a lot of other things that she can potentially do that's much worse than this, for sure. I mean, one thing I can do, for example, is that I can gather information. Okay? So if I want to see, for example, the SSN numbers of all the employees in the database, then I can do that as well. So I can go and just select from the HR schema employees because I know that there's a table called that from my previous SQL injection query. So I do that, and all of a sudden I see the SSN numbers for all the employees in the database. Now, I'm pretty sure that Bill Gates' social security number isn't 1, 2, 3, 4, 5, 6, 7, 8, 9, or someone's in trouble. But you can see that this is how an really easy way for someone to get information that they're not supposed to get access to and steal this information. Now, it doesn't really stop there either. So, if I'm connected to the database as a high-privileged user, which a lot of applications do, unfortunately, and in this case, it's exactly the same thing. So I suspect that this is the case. And so what I'll do is that I'll see if I can actually execute arbitrary commands on the machine itself. So everyone knows about XP command shell. And XP command shell is sort of a dangerous extended store proc because it lets you run arbitrary code on the server through SQL Server. Okay, so SQL Server lets you execute Windows commands through itself. Now, by default, it's off. And it's off for a very good reason because it's quite dangerous, right? Someone can attack your system like this. They can actually go there and start doing damage outside the database. So I'm going to see if I can actually, enable the XP command shell. So, you can use the SP configure, XP command shell, and you can submit this. And no errors, so the command went through. Now that I think that the XP command shell has been enabled, I'm just going to do a simple thing like maybe list the directory of the current executable. And if I do that, then I see that I get the list of directories for the current execution of SQL Server. Okay, so this is pretty dangerous, right? I mean, not only have we kind of expanded the damage that we can do to the data in the database, but we expanded it outside the database as well. And this is all done through a simple SQL injection. Okay, it has nothing to do with the server at this point. It's for the fact that the application is composing bad SQL, and people are taking advantage of it. So going back to the slide now and continuing with our presentation, we see that applications do need to care, and I'm going to talk a little bit more about that. And then I'm going to start talking about data protection. And data protection means things like the authentication, the encryption, things like that you can do to protect your data from the application point of view. And then application role separation. So role separation is quite important, especially with people facing compliance needs these days. You need to make sure that you strictly and tightly scope the permissions that your user, the application user, can actually access in terms of the database. And then, of course, I'll talk a little bit more about SQL injection, and we'll go back to the example that I just presented. So why do applications need to care? Well, judging from the show of hands earlier, I think that most people here understand why they need to care. But just in case you need additional information, the data security is not complete without application involvement. I can put several layers of security on the server side and make it really, really tight, but if the application is insecure, then you've created a hole to that data. Okay, the attacker just has to go and attack the application now. And as I mentioned before, SQL injections are now one of the most common types of attacks on the web. And in fact, a recent study by White Hat Security claims that SQL injections have infected or have attacked 1.5 million web pages on the web in the last year alone. Okay? And so these web pages include the the Department of Homeland Security. It also includes Sony, includes, I think it was CIA. But you can see that this is a very endemic problem. Okay? It's not just limited to any small website. These are very, very big websites that we're talking about. And in addition to that, applications can control or influence the encryption directly, the authentication that's used to connect, the permissions, and also the vulnerability SQL injections. So this is all done at the application level. Okay? There's some things that the server can do, but I'll talk a little bit more about them in turn. So let's start talking about data protection. And when you start talking about data protection, what's the number one you think of? A lot of people think of encryption because they think that if I encrypt the data, I've protected it from other people. Which is true, but you have to consider the fact that the encryption actually provides an extra layer of security. Okay, and so it's actually providing security, but you still have to rely upon the permission model that the database provides. But it does provide security so that if someone does have access to the database and maybe the same schema, you could potentially block them from seeing the data because they don't have access to the keys, for example. And in fact, a lot of compliance regulations, notably PCI, are now mandating that you have encryption enabled to protect your sensitive data. So PCI is interested in the credit card information, the credit card numbers. HIPAA, it doesn't explicitly spell it out, but a lot of people kind of interpret it to mean that confidential patient data should be encrypted to protect it from unauthorized eyes. And then in SQL Server 2000, just go way back, we didn't really have any encryption functionality. So you basically had to use a third-party tool to provide encryption at the application level. And so in 2005, we went through a lot of work to actually provide cell-level encryption, which means that now you can encrypt information on a cell-by-cell basis. And to do this, we provided the objects for encryptions, the keys, and we provided a rich key hierarchy within the database itself to protect the keys. Because everyone knows that the keys are important. If you encrypt data, but you make it really, really easy for you to actually access and obtain the keys, then you've actually probably made things worse than they were before without encryption. And the reason is that you think that you're secure, but in fact you're not secure, and so you've got this false sense of security. Okay, so key protection is very, very important. In 2005, we actually allow you to protect the keys with the internal key hierarchy. So it gets protected, for example, by a certificate, which is protected by the master key, and then ultimately it gets protected by the operating system itself through DPAPI. But you can also protect it with a password, so which means that in order to be able to access a key, you have to provide a password. And this is also a valid solution. Of course, you do have the problem that you have to maintain this password, and the application has to be aware of it and protect it as well. Okay, so those are some of the considerations, but it does protect it from other entities in the database who don't have access to the password or knowledge of the password. In 2008, we kind of expanded upon the encryption functionality. And the two things that we actually added in this space is the transparent data encryption and the extensible key management. And both of these are more server-focused type of features, but I'll explain them really briefly. So the transparent data encryption is basically where we protect data at rest. So the data that's stored on disk is always encrypted. Now, it's called transparent because this is important to the application. It's transparent to the application because the application doesn't need to know anything's encrypted. In fact, it doesn't know that it's encrypted. It can connect. It can do everything that you can do normally without any kind of occurrence of having to change your schema or having to call built-in functions like you have to do with the cell-level encryption. And so this is a very, very good feature for people who need to satisfy the data rest kind of scenario, but don't want to change their application. Because I think everyone knows that that changing applications can be a real headache. And in fact, some companies don't even have the application source code and the ability to change your application anymore. So this is one consideration. The transparent data encryption actually is a good alternative in this case because it encrypts the entire database. You don't have to worry about forgetting to encrypt certain objects. For example, you may leak information if you encrypt the table, but potentially you didn't encrypt the indexes or something like that. Okay, and also it's very performant. Okay, in the sense that it actually on typical workloads it takes about a 3 to 5% performance hit on the server side, whereas the cell-level encryption you'll incur a lot more. The extensible key management is also another good feature because what it does is it allows us to actually store the keys outside the database. Okay, so this is a very good security practice that most people advocate, where you want to store the keys separate from the data. Putting them together increases your exposure and vulnerabilities to attacks. So to the application, this doesn't make a difference at all because to the application, the keys still seem like they're in the database. It's just that virtually we have a pointer that points out to an external hardware security module. Okay, so these are things that your DBA should be aware of as well, and it can make things for your application much easier. Now, in terms of the cell-level encryption, because this is one that mostly affects application developers, that we provide the built-ins. So when you actually encrypt and decrypt the data, you call the built-ins to encrypt and decrypt the data. And we provide the DDLs for creating the symmetric keys. We also have asymmetric keys and certificates. Okay, and so you should understand the difference. Symmetric keys are much faster. Okay, they're meant for encrypting large blocks of data. But obviously the problem is that since it's symmetric, it means you use the same key for both encryption and decryption. In order to give someone the ability to encrypt the data, you've actually given them the ability to decrypt the data. So this is something you have to consider. Asymmetric keys solve that problem because it's just like PKI. It's a public key, private key pair. You can give someone your public key to encrypt the data, and they can encrypt it, but they can't decrypt it. But the problem here is that the asymmetric keys are actually quite slower in terms of performance. We're talking magnitude slower in terms of their ability to encrypt. And the certificates are very similar to asymmetric keys, except they have additional metadata associated with it, things like the creation time, things like that. The securing of the keys themselves, I mentioned this in the earlier slide. You can do it based on password. That kind of moves the onus on the application to actually maintain the password and make sure that it doesn't get discovered. And you can have it automatically done within SQL Server, and that's probably the most convenient type of scenario. But just keep in mind that if it's inside the database, then the privileged users can potentially get access to the keys. Okay, and you have a wide choice of algorithms. We go all the way from DES, which I hope no one's using, And in fact, I think that no one should be using it anymore. But it's there for legacy purposes. Triple DES, which is better than DES, except that it's still not the greatest algorithm right now. It can be broken, and it's actually quite slow. The new standard is AES, and we support AES all the way from 128 to 256-bit keys. Okay, so you should consider using AES, and depending on your needs and depending on the performance of your machine. And so the best practices here are that you want to make sure you encrypt only the data that's necessary. Okay, the cell-level encryption actually incurs a significant performance hit. You'll notice if you're encrypting large amounts of data. So as a result, you want to really encrypt only the piece of data that you need and leave everything else in clear text. So you got to do analysis of what's important and what's not. Try to use symmetric keys whenever possible, because as I said, the performance benefits. There's a big difference, and you'll notice it if you just play around with it. And plan carefully. Plan on how you want to do your key management, how you want to store your keys and protect them. And understand that when you start using cell-level encryption, you have to make changes to your application, because you're going to have to call the built-ins every time you encrypt and decrypt, or you select or you update data. And consider the key size on the CPU. So use the maximum key size you can without incurring a significant performance hit on your machine. Encryption by its very nature is very, very CPU intensive, as everyone knows. So you have to strike the right balance. Now let's talk about another type of encryption, channel encryption. So people may not know, but we've had full SSL support for channel encryption since SQL Server 2000. And as long as you're using a 2000 server or above, and using an MDAT client of 2.6 or later, which I'm sure almost everyone is, you're using probably the 80.NET driver or something, you can do encryption, okay? And you can actually enforce encryption both on the server and the client side. And here's the difference. If you enforce encryption on the server side, it means that every connection that comes in must be encrypted, or else the server is going to disconnect, okay, not allow that connection to come through. From the application's point of view, they can choose to encrypt whichever connection that they want to use. I mean, you can choose this connection to be encrypted and this connection not to be. And it's a connection string parameter. And one of the actual additional benefits of enforcing encryption on the client side is that you also get the ability to actually validate the server certificate. So when you do SSL, the server sends you its certificate to do the encryption of the data on the wire. The client will actually validate to see that that certificate is coming from has the same host name in the certificate as reported by the communication stack. And if it's not from the same source, then it knows that this is probably not the right certificate, and it's going to disconnect. And also, if you force client encryption, then if the server doesn't support encryption for whatever reason, then it will disconnect and it won't continue as well. Now, one thing that people may or may not be aware of is the fact that login packets are always encrypted in SQL Server. Okay, so the login packet is the packet that contains your credentials. For example, if you're using SQL authentication, it contains your user ID and password. And whether you turn on encryption or not, we will always try to encrypt that packet. Now, in 2000, people may have noticed that, well, I see, if I do a network sniffer trace, I see that the password's flowing in clear text. The reason there is that in 2000, the server could only do SSL encryption if it was able to have a certificate provisioned on the machine. Okay, so someone had to go and put a proper certificate, load it onto the machine, and SQL Server picked it up. Now, if it couldn't find a certificate, then there's no SSL encryption at all. But in 2005 and 2008, what we do is actually, if we can't find a valid certificate, we create our own. It's a self-generated, self-signed certificate, and use that for the encryption. Now, the obvious downside is that if you start talking about self-signed certificates, it doesn't have a root authority with which you can verify the validity of that certificate. And so we still use it, but it's not as secure as using a full-blown official SSL certificate that you can buy from RSA or from your Microsoft server, Certificate Authority. So just to rehash, if we start talking about the best practice for channel encryption, it's very simple. You want to enable channel encryption whenever it's possible and tolerable. And the reason I put tolerable is that anyone who's used SSL understands that it's a fairly heavyweight protocol. Okay, you're encrypting every single packet that goes back and forth using strong encryption. And also, provision a certificate on the server. I've told you why it's bad to use a self-signed certificate, because you potentially have problems with validation. The client won't be able to validate the certificate because it's coming from the SQL Server itself. There's no root authority. And for that reason, try to enforce encryption on the client side. Because if you enforce encryption from the server side, the client doesn't necessarily do the server validation. Okay, so that's the most secure. And if the client does server validation, then you've kind of mitigated man-in-the-middle attacks to some degree. Okay, and so man-in-the-middle attacks where someone injects themselves between the client and server and starts either relaying or modifying the information that gets sent back and forth. I'll talk really quick about authentication. And everyone knows that we have two types of authentication in SQL Server. One is SQL authentication and one is Windows authentication. So SQL authentication is basically the user ID password that you provision inside the database itself. And then Windows authentication is where you use your Windows credentials to actually connect to the database. And SQL Server doesn't actually choose which type of authentication we use if you're using Windows Auth. We let Windows decide. So Windows will try to use Kerberos, and if the conditions aren't right for using Kerberos or it can't be used, then it'll fall back to NTLM. And in most cases, you want to use Kerberos. Kerberos is the strongest authentication mechanism that we currently have available to us. And it has a lot of nice features, such as, it prevents replay attacks, where someone could take the pack and try using it again as a way of accessing the server. It also allows you to do mutual authentication, which means that not only is the server validating the identity of the client, but the client is now validating the identity of the server. Okay? And so these are things that you can't necessarily do with SQL authentication unless you have SSL encryption turned on. And the logins are also managed by Windows in this case, right? So in some cases, the database administrator wants to administer all his users. He wants full control over it. But you have to do it on a per database basis. And if you use Windows authentication and you're dealing with domain accounts, for example, you have a centralized management of all your users. And because of that, if you have user Bob on server A and user Bob on server B, and this is through SQL Auth, then these two users aren't necessarily the same. They just share the same name, but they're two distinct users. Whereas if you have Windows domain user Bob and Windows domain user Bob on server A and server B, then they're necessarily the same user because they're coming from the same set of credentials. Okay, so this is using Windows Auth, I'm saying, is one way of actually persisting the identity across different servers. And in terms of policy enforcement, well, policy enforcement obviously works for Windows authentication. If you're using Windows 2003 or later, we actually tie into Windows to use their password policies for the SQL accounts as well. Okay, so overall, I mean, there's pros and cons for using both of these types of authentication mechanisms. But in general, most people prefer Windows authentication because of increased security and the ease of management. So it depends. And the application has control over this too because they can control how they authenticate against the server. Now, in terms of authentication in 2008, we did make some enhancements. And the enhancements are around Kerberos. And as I mentioned before, you want to use Kerberos as much as possible if you're using Windows authentication. And in 2005, Kerberos was only actually available on TCP/IP connections. So if you connected to the server using name pipes, you're pretty much using NTLM. You're guaranteed to be using NTLM, in fact. And you needed to have the service principal name, or the SPN, registered in Active Directory. The SPN, or service principal name, is basically the target of who you're authenticating against in Kerberos speaks. And you need to register this in Active Directory. Now, SQL Server, when it starts up, it tries to register it for you, for the server, but it almost always fails. And why does it fail? It's because in order to actually register a SPN, you need to be a domain admin. And most people don't run SQL Server under a domain admin account. I mean, that'd be kind of foolish. So what we've done in 2008 is that we made Kerberos available on for all the different protocols. So whether you're using TCP/IP or name pipes or VIA, you'll still get Kerberos authentication if the conditions are right. And the SPN can actually be specified in the connection string. So when the client actually tries to connect, it composes the SPN based on the information it has about the host name, based on the instance name, things like that, and constructs this SPN that it uses to try to search the AD for. Now, sometimes they don't really match. What you have registered in the AD may not be the same as what you have, what SQL Server on the client composes. And so you're going to get a NTLM by default in that case. And so we allow you to actually explicitly state what the SPN should be on the connection string. And now a side benefit for this is actually because of that, you can actually get Kerberos working without even registering SPN in the AD. And the way you do that is that the SPN is basically the identity of the service account of SQL Server. So when you specify your connection string, you can specify as your SPN the service account. So if my SQL Server instance is running under bob@microsoft.com, I can just say my service principal name is bob@microsoft.com, and you can get Kerberos authentication working between the client and server in that case, all without having the SPN registered in Active Directory. Okay? So you may not need to actually go and bug your domain admin to register this for you. If you have any questions, please feel free to interrupt me. Otherwise, I'll just keep going. Question? The question is there any way to prevent it from using NTLM? So this is actually more of a question for Windows because, as I said, we don't actually control which authentication we use. Currently, we let Windows negotiate it. Now, I don't know exactly what Windows plans are. There's always been talks about a way of disabling NTLM at the operating system at some level. I think that the best thing would be to talk to the Windows 7 guys, and I'll actually follow up with them as well. But if the operating system can actually provide an option to disable NTLM, then SQL Server automatically will be NTLM free in that case. Question? So the question is, if you go from a 2008 connection and you have a link server to 2005, whether you have the credentials go all the way through? The answer is yes. So if you're using pass-through authentication where you're just using the same Windows context, then that does get passed through all the way. So that hasn't changed since 2005. Any other questions? Question? So the question is there any way to use Windows authentication without being on the same domain? And the answer is yes, but you're not going to get Kerberos. Kerberos mandates that you have to be on the same or trusted domains, the client and server, I mean. You can do it through two machines that aren't in the same domain, but it means that you'll be using NTLM. Okay.
When you use Windows authentication, you try connecting, it doesn't actually allow you to pop up a box to type in your domain information?
So the comment is, does Windows allow you to pop up a box and type in your domain information? The answer is no. It doesn't do that at this point. Was there another question? Yes? So the question is, there's a way of in SQL Server, there's a way of actually disabling password policy. And your question is whether we can enforce that? Yes, there are trace flags, and there's a KB article written for this, but there's a trace flag where you can disable password policy checks on the server itself, in which case SQL Server will never go and check this anymore. Okay. Any other questions, or can I continue? Okay, let's keep going. Let's start talking a little bit about application role separation permissions. This is coming up a lot these days, and so I thought it was important to talk about application role separations and the permissions we have associated with it. If I can employ you to do one thing, okay, it's the first bullet on the slide right there. Follow the principle of least privilege. It's very, very important. If you do this, you'll solve a lot of your problems. And what this principle is basically you give someone the permissions they need to do their job and their task and nothing more. And specifically, don't give people sysadmin or DBO rights just because it's easier. Because what you've done now is, like in my SQL injection example, because they have sysadmin rights, they're able to go in there, they're able to hijack your connection or attack your application and get access to a lot of things that they don't need to. Okay, so it's very, very important to follow that principle. Don't use the DBO schema. The reason is that I understand that there's historical reasons for using the DBO schema. Way back, the only way to create a schema was actually to create a user. And so if you got rid of the user, then, I mean, if the person left the company, you couldn't get rid of the user because, well, the schema was still being used. That's no longer the case in 2005 and 2008, okay? Previously, the DBO schema was the only constant that you had in the database, so people stuck stuff in there. But of course, if you put things all into the DBO schema, then you don't have the separation now. Everything's under one owner. Everything is all under one database. You can't separate things out by schema. So it becomes a little bit more difficult to actually do fine-grained permission control. And in 2005 and 2008, the user and schemas are no longer kind of tied together anymore. So you create a user. It doesn't mean that you have the same schema. You have to manually create a schema. It doesn't have to be the same name. And if that user decides to leave the company, you can get rid of the user, and you can keep the schema, and then you can give the schema to a different owner. You can reassign it. Okay, you can do all sorts of things like that. So it's no longer necessary to use the DBO schema for anything. So you should probably have different schemas. And in fact, a good practice is actually to create a different schema specifically for your application. So you have your application, you know what objects it has to touch or get access to. You put that in one schema. Everything it doesn't need access to, you can have that in a different schema. And by doing this, you can actually grant permissions for the application user to that one schema, but not to the others. And so you basically kind of sandbox them now. They can only go to that one schema. and they can only get access there, but they can't go outside of there. So you've kind of created this role separation. And leverage flexible database roles. So this is going to make things a little bit easier for you because instead of assigning permissions to every user, you can create your own role and just start putting users in there. If that user ever leaves a group, just take them out of the role. Okay, so it's a really, really good way of actually lowering your administrative costs. And consider auditing your user activity. In 2008, on the server, we provided a rich security auditing functionality. And what this can do is, if you're concerned about access to a specific table, for example, we now have the ability to say that I want to know whenever anybody goes and does a select from this table, and that's all we're audited. Previously, the server can set up a trace, and then you had to post-filter all this information. Now in 2008, that's no longer necessary. We target the audit, and so it makes things a lot faster. In fact, I can even say that I want to know whenever user Mallory selects from the table, and it'll only capture this event when Mallory explicitly does a select on the table, and that's it. Okay, so this is a good way of actually keeping tabs on who's doing what, and for auditing purpose and kind of analysis of what went wrong. I would show you an example, but unfortunately, I think with the 45-minute session, it's not going to be very easy to do in the time allocated. But I can definitely talk more about it if you guys want after the session. One thing that I want to actually discuss is ownership chaining, because sometimes this catches a lot of people off guard. Okay, and it's actually a really, really important thing to understand in terms of the permission model. So in this example here, this is the best way of actually explaining it. Bob wants to execute the hr.proc1. The HR schema is owned by Alice. So Alice grants Bob the ability to execute the store proc. Okay, fair enough. Now, when Bob executes the store proc, we do the permission check. We want to know that he has permissions to execute this. It checks out. He's fine. Now, this store proc happens to access a view, which refers to a table. Okay, they're all both within the HR schema. Now, Bob doesn't necessarily have access to view 1 and table 1. In fact, he might even have a deny. But what's going to happen here is that everything's going to succeed. And the reason is because of ownership chaining. Ownership chaining says that if you have objects that are all owned by the same individual, then we're going to bypass the permission check. Okay? So what happens in this case is that he runs proc1. Proc1 is owned by Alice. And it accesses view 1, which is owned by Alice, which accesses table 1, which is owned by Alice. So in each of those two steps, we actually bypass the authorization check. And so how do you break the chain? Well, if the owners are different, you have these objects assigned to different owners, then the chain necessarily gets broken because they're not the same person. And so we will actually go through and do a permission check at each step. Okay, so be aware of this. Sometimes you may, even though you denied access to table 1 to Bob, he may have a way of getting to it because of ownership chaining. Another thing I want to talk about is module signing. And this is a really, really cool feature that, unfortunately, I don't think a lot of people are actually familiar with. If we take this example here where Alice, who's a non-privileged login, so she's not sysadmin, and she wants to enable Bob's login. Maybe Bob's login's been disabled for whatever reason. So she wants to alter the login Bob enable command. And what happens? It fails. And the reason it fails is because in order to do this, Alice needs to alter login server permission to alter the login, and which she doesn't have. And so do we want to grant this permission to Alice? Well, probably not, because it's actually a fairly powerful permission. She'd have access to all the logins and be able to do things, enable, disable, change passwords, whatever she wants. So it's a very, very bad permission to give to any arbitrary person. So what do we do in this case? We still want to allow Alice to be able to issue this command. Well, the solution is that we can wrap it in a stored procedure. We'll call this SP enable login. And then we give Alice the ability to access or execute the stored procedure. Now, what we do is we sign it with a certificate, and then to the certificate, we associate a user, which to the user, we give the alter any login permission. So what's going to happen is that when Alice executes the stored procedure, she is automatically going to be able to enable Bob's login, because when she executes the stored procedure within the context of the stored proc, she actually gets this alter any login permission. Okay? And it's all done within Alice's context. Okay? So Alice hasn't changed to anyone. She's not executing as anyone else. She's still executing as herself, but she has this extra permission while she's running the stored proc. And in case you're afraid that she may modify the stored proc and do all sorts of other nasty stuff, when you sign a stored procedure with a certificate, it means that if someone tries to tamper with it, the signature becomes invalidated, and SQL Server will not run it. Okay? So signing is a great way of actually preventing people from modifying your stored proc and for giving people additional permissions that they don't necessarily have and trying to scope that down. So module sign is a very, very powerful feature, and I think that it's something that you should consider if you have a scenario such as this, where you want to grant specific permissions to do something, but not give them the full-blown permission to do it. Now, let's go back and talk a little bit about SQL injection. So I think everyone here knows what SQL injection is, and you guys saw right at the beginning I showed you how easy it is to exploit. But this is spelled out. SQL injection is an attack where malicious code is inserted into strings, and then the parser will actually parse it out so that it ends up executing that additional string that you have. Okay, so it's actually very, very kind of, it's sort of a very, very kind of devious kind of way of attacking someone, because there's no real bug error here. It's just that they're exploiting the way that the language is architected, or when the application is architected. And again, SQL injections are very, very common and can affect all types of applications. Okay. So I want to show you exactly how we would fix that application that I had at the beginning of this presentation, and show you the things that we can do to try to make it more SQL injection proof. So let's go to the application itself. And can you guys see it? See the code? I'll zoom in, actually. So this is the ASP application, ASP.NET application. And one of the first things we want to do in an application, okay, so you saw that when we entered the quote at the end of the name, it barfed, right? It came back with this error that hackers are well aware of and they search for. So what you want to do is you want to have proper error handling. So in this case, what I want to do is that I want to have an on-error go to error handle. And in the error handle block, all it does is it actually kind of cleans out the error and puts out generic error for everything, okay, so that there's no way of telling what actually happened, you know, at least from the application's point of view. So that's step number one you want to do. The second thing that you want to do is that you want to change the execution context. Remember the principle of least privilege? Well, right now, one of the main problems that we had with this web application was the fact that we're running as a very privileged user, a sysadmin, in fact. They're able to do all sorts of stuff, right, like enable XP command shell and things like that. So what you want to do is you want to connect using the lowest privilege account that you can get away with in terms of making your application still function. So in this case, we're going to just use a user ID called lowpriv_app_user. Okay, this user account was created explicitly for the application itself. So now we're no longer going to go and connect to sysadmin. So even if they were able to exploit this, they wouldn't have been able to actually, you know, execute the XP command shell. So that's step number two. Number three is we want to sanitize the input. Okay? We know that the input is going to fall under certain parameters. It's a name. Okay, so it's a user ID. So in that case, we know that the user IDs are going to be alphanumeric. You know, in this case, we know that they're all alphanumeric and they're always less than 126 characters, or 25, I guess. And so in that case, we're going to use the regular expression. Oops. We're going to use the regular expression to sanitize the input. So in this case, if it has anything besides alphanumeric characters, then we're going to flag an error and say that this isn't valid. And we know right there that we should stop. Okay? And that in itself should prevent the quote, right? Because we don't allow quotes in this regular expression. And the last thing that we want to do is that we want to parameterize our queries. Okay? So parameterization is basically a great way of actually separating the execution text and the data that's passed in from the user. Okay? Whereas, you know, if you just concatenate strings together, it's just one big string that's a mixture of user data and the, you know, predefined statement. Well, parameterization actually makes it clearly defined what's data and what's parameters inside the query itself. And so that's fairly easy to do. I'll just uncomment these. And you can see right there that all we're doing is that we're adding a parameter for the actual username that's entered. And I will comment out this right here because we're no longer going to just concatenate the strings. And that's pretty much it. You know, so we've made this query a lot more resistant to SQL injection. And I'll try to show you now. Let me restart this. Okay. So let me restart. And now, if it comes up, I'm going to try to do the exact same things I did before and try to see if I can exploit the exact same problems. Is it coming up? Here we go. Okay, so if I go back to one of my earlier SQL injections, okay, so I want to go and perhaps I want to see what the schema is of the tables in the database. So I go Mallory again. I'll use the same trick, quote, semicolon, and add whatever I want. And if I submit this time, well, I get a generic error back, unexpected result, please contact the administrator. You can put whatever you like in there, okay? And it failed, and you can see up there that it failed a regular expression check. So right now, the same exploits I used at the beginning of this presentation no longer work for this application. And we made this 100% more secure. So it's as easy as that, just following those principles. Now, in terms of spelling it out, here's some strategies you can have against preventing SQL injections. You just saw this, validate the input against a whitelist. Okay, that's a very, very easy thing to do. Parameterize your SQL queries. That in itself will help you immensely against SQL injections. Use parameterized SPs as well. Least privilege principle, and that also applies to the web services. Because often when you connect through a web service, you're going to connect as a service account. So make sure you use the least privilege principle there when you choose account. And escape special characters and validate buffer lengths to avoid truncation. Okay, very simple things you can do that actually have a big impact on the security of your application. In terms of tools, at the beginning of this year, actually, there was a huge surge in the number of SQL injections that started occurring on the web. And a lot of them were actually affecting ASP applications. Okay? And the reasons for this huge surge is because, first of all, people were developing tools to automate these SQL injections. It's very easy to just go up to a website, create a SQL injection, and all of a sudden, bam, you have it. And you could create these bots that would actually go and exploit SQL injections to kind of propagate themselves to other servers. And so you had this big kind of explosion. So one of the things that we've provided is a tool to help you kind of identify SQL injections in your code, potential SQL injections in your ASP code. Now, obviously, it's not going to be able to tell you everything, but it will be able to point out a lot of the very obvious and very kind of standard type of flaws in your application that can lead to SQL injections. And so I'll show it to you right now. It's actually fairly easy to use. Whoops. Oh, here we go. So here's a simple ASP application. And you can see right there, the main problem that we have is this right in the middle there where it says string command equals select title. And so you can see right there, all we're doing is we're concatenating a string with user input. Very, very bad thing to do, right? And so this is something that's a big flag to people. And if you're coding this, you should probably be able to tell right away that this is a potential injection. But suppose that you forgot to check. Well, you can run this through this actual executable, this checker. And the way you do it is there's a executable called mscasi _ asp.exe. And then you give the name of the input. And when you do that, you get this output. And the first thing you see at the top is warning, unvalidated HTTP request data possibly executed, making varbin potentially vulnerable to first-order SQL injection attacks. So right there, it tells you that you're vulnerable to a first-order SQL injection attack. A first-order SQL injection attack means that you're taking user input directly and putting them into your SQL statement. Second order is where you're actually taking the user from, say a database. Okay, so you have data stored somewhere in another database. You take that out to maybe create your input for your statement. Now, if you look at the first line there, it says the file name and then has 37, which means line 37. And if I show you what line 37 is, it's hard to go in here, but whoops, it's hard to show in Notepad, but I know exactly what it is. It's this line right here, which is the execute. So that's the source of the problem. Now, in terms of the other input or other information on this thing, you'll see that it says form 11, which means that on line 11, that's where we actually had the form command to actually take in the actual input from the user. So if you go to line 11, it's right there. You can see it where it says string author equals request.form author name. So take a look at this. I put the URL in the slide itself, so you'll be able to go and find this tool, play around with it, use it against your ASP.NET, or I'm sorry, ASP applications. There's no ASP.NET tool yet. The team is working on that, but for now, use the ASP the tool. And for everything else, I want you to, well, we just did the demo. I want you to consider these things from this session. I want you to consider encryption. Okay, so encryption isn't always the right answer, but in certain cases, it can provide you a huge amount of benefits. And make sure you're smart about using encryption. Okay, don't just blindly use it because you'll be very unhappy if you do that. And carefully think about permissions. Okay, don't just, as I said before, use sysadmin because it's easy. you're going to cause yourself a lot of pain later on if someone actually ever exploits your application. And you want to maximize the role separation, kind of clearly define what people need and what they don't need. And always be mindful of SQL injections. Okay? This is very important because if you don't, that's probably the time that you're going to find yourself in big trouble. I have some additional information, but that's essentially it for this session. If you have any questions, I'll stick around for a bit longer afterwards, and I can try to answer them. But otherwise, I'd like to thank everyone for coming to the session, and please fill out your evaluations. I think you guys have been heard.